Question number 46. When a silicon diode having doping concentration of Na and Nd value is given and it is reverse biased, applied in reverse bias, then the total depletion region width will be 3 micrometer. Total depletion width is given 3 micrometer. Given that the permittivity of the silicon is given, then he is asking that the depletion width on p side depletion width asking, and maximum electric field in the depletion region is what? We need to find depletion width on p side and maximum electric field we need to find. So he given that a silicon diode is given, this is p side, this is n side, and it is applied in reverse bias. It is applied in reverse bias. Then the depletion width will be formed. The depletion width will be formed. Then he is asking that p side depletion width is how much? He is given the total is 3 micrometers. He is asking the p side depletion width is what? How much? And he is asking the one more thing is maximum electric field present in this depletion region is what? We will see how we need to proceed, and this is also we will see in graphical way, in neat and good way. We will see. This is the PN junction diode. This is the PN junction diode. This is P side, this is N side. He given Na for P side, and is N side is given, and also he given the total width is given. This total width is given as 3 micrometer. Then now he is asking that this N side depletion width is how much? N side is how much? And total maximum electric field is how much? By observing this, this is negative ions are formed this P side, and positive ions are formed this N side. So the total charge graph will we observe this charge. N side we will get the negative charge, P side we will get the P side we will get the negative charge, N side we will get the positive charge. From this the electric field observed negatively directionally it is negatively decreasing, but maximum is present in depletion region only. If you doped with the same number of Na and same number of Nd, means both are equal, then the depletion region width will be exactly at the middle point of the depletion region. But by depending on the values of doping values of the Na and Nd, the maximum position is shifted or left or right, but it should be present in depletion region only. Within the depletion region only, maximum electric field will be present. So we need to find these two things. One is maximum electric field and depletion width on P side, Wp. We have two formulas for this. For this, there is a formula: P side width into acceptor concentration is equal to N side width into depletion width. Width means N side width into donor concentration. By this, we will get P side width. For this, there is a formula: E maximum is equal to charge into N side width into Nd by permittivity. We can also write the for maximum electric field, charge into P side width into acceptor concentration by permittivity. These two will give the same results because these two multiplications are equal. So if we use this formula or this formula, we will get the same maximum electric field. So we need to remember these two things. These two formulas we need to remember. This is one. In these two, either only one is correct. Only one is not correct. Both are correct if you choose according to your convenient. So we will be given the Na value, Nd value, and total width and permittivity. By using this data, we will get our required P side width into acceptor concentration is equal to N side width into donor concentration. We also given total width is given, means P side width plus N side width is equal to 3 micrometer. From this, W1 is written as 3 minus WP in micrometer. Just substitute this in equation. Then WP into NA is equal to WN means 3 minus WP width is equal. From this, but we know all these values. Thus, equation he given these two values, and there is only one unknown value is WP. By substituting these all the values, we will get the WP is equal. I am not substituting, just substitute all the values and get the answer as 0.3 micrometer. Then Wn is 3 minus 0.3 means 2.7 micrometer. This is from P side depletion width. This is from N side depletion width. Why we get P side is less width and N side is more width? Because P side doping concentration is more, because that 9 into 10 to the power of how much? 9 into 10 to the power of 16. 9 into 10 to the power of 16. From N side 1 into 10 power 16. Because 9 into 10 power 16 per centimeter cube, and N side 1 into 10 to the power of 16 per centimeter cube. So doping concentration is more, then depletion width will be less. Doping concentration less, depletion width will be more. Here we also know the another concept is depletion width. Depletion width is inversely proportional to the doping. So we got the one answer as 0.3 micrometer. Just to verify the options. 0.3 micrometer. This is 2.7. This is N side, but he is asking the P side depletion region. P side depletion region is asking. So this is wrong. 2.7 is wrong. 2.1 is wrong. 0.3 is correct. 0.3 here and here only. But we need to find electric field. Whether this or this one correct. Either B or C. We need to remember. We need to calculate. We know the formula for maximum value. Electric field maximum value is equal to charge into N side width into doping concentration by permittivity. He given in question all these values. Q value we know 1.6 into 10 to the power of minus 90 coulombs charge, and width N side width we get the N side width as 2.7. ND value is given, permittivity also given. Just by substituting all the values, we get the answer as 4.15 into 10 to the power of 5 volt per centimeter. This is maximum electric field present in the depletion width. We get the two values 0.3 micrometer and 4.15 into 10 power 15. 10 power 5. 4.15 into 10 power 5. This B is correct option. C is wrong. B is correct option. So just only given the P side, N side, NA value and ND value. Total width is given. He is asking the P side width, and also he is asking the maximum electric field. Just by observing this graph, clearly we come to one conclusion. In some questions, he also can given this graph. From this graph, this is voltage graph, barrier voltage graph. From P side negative voltage, N side positive voltage. Just by remembering these two formulas, we get the answer. two formulas. Please remember these two formulas.